X and Y are two random variables, and y1 and y2 are also random variables which are using the random variables x and y, right? Y1 is combination of random variables x and y, and also y2 is a combination of random variables x and y, which includes some trigonometric terms. Next one. Here is asking about covariance of y1 and y2, right? Covariance of y1 and y2. What is the formula for covariance? The value of what is the formula for covariance?
Covariance of x comma y is equal to e of x comma y minus e of x into e of y.
Okay, covariance of x comma y equal to e of xy minus e of x into e of y. Right? Here we have to find out the covariance of y1 and y2. Y1 and y2. Then the formula becomes covariance of y1 comma y2 equal to e of y1 y2 minus e of y1 y2 minus e of y1 into e of y2. E of y1 y2 minus e of y1 into e of y2, right? That means first we have to find out the term e of y1 y2. What is meant by e of y1 y2? E of y1 y2 అంటే ఏంటమ్మా? దేంతో ఇండికేట్ చేస్తున్నాం? y1 y2 is nothing but correlation. E of y1 y2 is nothing but the correlation, right? Here E of y1 y2 equal to E of expectation of what is y1? X cos theta plus y sin theta. What is y2? Minus x sin theta plus y cos theta. Okay. If you multiply both these terms, x cos theta plus y sin theta into minus x sin theta plus y cos theta. Multiply both these terms, we will get this equation. We will get this equation. Okay. Common terms are sin theta cos theta here and also sin theta cos theta here. If you take both as common, it becomes minus x square plus y square. Minus x square plus y square, right? Plus here we have to take xy as common, xy, and which is cos square theta minus sin square theta, right? Cos square theta minus sin square theta. So apply expectation. Here sin theta cos theta terms are constant, then which is e of y square minus x square plus e of xy. Then sin theta cos theta into e of y square minus x square is equal to e of y square minus e of x square plus cos square theta minus sin square theta. Cos square theta minus sin square theta is equal to cos 2 theta, right? Cos 2 theta into e of xy. Cos 2 theta into e of xy. This is the term we get from e of y1 y2. This is a simple mathematical calculation. Minus e of y1 into e of y2. E of y1. That means e of what is y1? X cos theta plus y sin theta. And also e of y2, which is equal to minus x sin theta plus y cos theta. if we're applying expectation for both these terms, cos theta into E of x plus sin theta into E of y into sin theta into E of minus x plus cos theta into E of y. Cos theta into E of y. This is a simple mathematical calculation. If we solve these equations, we will get E of y1 into E of y2 equal to E of y1 into E of y2 equal to sin theta cos theta into E of y square minus E of x square plus E of x into E of y cos square theta minus sin square theta cos square theta. Now finally, covariance of y1 comma y2. That means you have to substitute both these equation terms we get from E of y1 y2 and E of y1 into E of y2. We subtract these terms like this. Then we have to simplify this equation. Is cos theta sin theta into variance of x minus converted it into some variances. So we simplify it, we will get these equations. Second one. What you asked in the second one? We have to find out for what values of theta y1 and y2 are correlated. I mean uncorrelated. That means covariance of y1 comma y2 is equal to 0 for uncorrelated values. That is 0 equal to 1 by 2 sin 2 theta. That means we have to take this equation directly. This is covariance of y1 comma y2. And if we equate this into 0, then we get these terms. This is theta equal to, this is simple trigonometric calculations. Finally, we get theta equal to 1 by 2 tan inverse 2 into covariance of x comma y by variance of x minus variance of y, variance of x minus variance of y. Okay. మన లాస్ట్ క్లాస్ లో ప్రాబ్లం ఆన్సర్ చేశారు ఎవరన్నా ప్రీవియస్ పేపర్ ప్రాబ్లం ప్రీవియస్ పేపర్లో చేశారా లాస్ట్ క్లాస్ డిస్కస్ చేసాం కదా ఫార్మర్స్ డిస్కస్ చేసాం చేయమని చెప్పాం కదా ఎవరు చేయలేదు అయితే ఓకేనా The next one is చూడమ్మా ఒకసారి. Already we have discussed that in third unit there are two parts. First one is multiple random variables and second part is operations on multiple random variables. Right. Operations on multiple random variables. Now I will brief you about operations on multiple random variables. If anyone missed the previous classes about operations on multiple random variables, please listen. Please listen. If in operations on one random variable or multiple random variables, these all are comes to find out the different parameters and characteristics of the distribution function, whether it is single random variable or multiple random variables. Now the basic term I have involved in this is moments, right? What is the first order moment about origin in single random variable? In single random variables, what is the first order moment about origin? Respond. First order moment in single random variables.
E of x power n is equal to
Okay, of
integral
x
minus infinity infinity xn of
minus infinity x power n and above x.
sir,
I asked about first order moment.
sir.
First order moment. What is meant by first order?
Mean, sir.
Mean. If you substitute n is equal to 1, becomes the
Mean,
first
sir.
order moment about origin, right? Also, second order moment about origin is nothing but mean square value. Like this also, here also there are two types: joint moments about origin. Second one is joint central moments. Okay. In their first order single random variable, there is moments about origin and central moments, right? There are two types, major types. Actually, joint moments about origin. Okay. The formula for joint moments about origin is E of e of x power n into y power k. Is equal to double integral of formula చెప్పండి.
Double integral of
Double integral of
minus infinity to infinity x power n into y power k
x power n into y power k,
x power n into y power k
x power n
f
y
of
power
x
k.
comma y dx dy.
Yes, yes. Double integral of integral minus infinity to infinity x power n into y power k into f of x comma y dx dy. F of x comma y dx dy, which is the formula for joint moments about origin. Joint moments about origin. We want first order means if we substitute n is equal to 0, comma k is equal to 1. If we substitute n is equal to 1, comma k is equal to 0, we get what we will get if n is equal to 1, comma k is equal to 0.
E of x.
X power n into y power k integral minus infinity to infinity. Double integral. Okay. Now if n is equal to 1, comma k is equal to 0, we get
E of
n
x.
is equal to 1, comma k is equal to 0 ఏమొస్తుంది?
E of x.
E of x వస్తుంది. If x is equal to mean value of x. And also if n is equal to
And equal to 0 and k is equal to 1.
n is equal to 0, comma k is equal to 1.
E of y, sir.
E of y, which is equal to mean value of y. mean value of x, mean value of y. Now the important one is n is equal to 1 comma k is equal to 1. If n is equal to 1 comma k is equal to 1, here is of xy.
E of x comma y correlation, sir.
Okay. If n is equal to 1 comma k is equal to 1, we get E of xy. What is E of xy? E of xy is nothing but the correlation of x and y. These are the formulas we are used in the problems. And in some previous papers, they asked about explain correlation and their properties. N is equal to comma k is equal to 1. These two are called first order moments, first order joint movement. These are called first order joint movement. This one is second order joint movement. Second order joint movement, right? So substitute different values for n and k. You will get different parameters like mean, variance, correlation. Okay, mean square values, and so on. This is about joint movements about origin. What we will get if we substitute n is equal to 2 comma k is equal to 0?
Mean square of x, sir. Mean square of x, E of x square.
E of x square వస్తుంది, which is nothing but mean square value of x. E of x square. Which is equal to mean square value of x. Okay, and so on. K is equal to, you will get mean square value of y. Okay. These are about joint moments about origin. Next one is joint central moments. These are also similar to the above formulas. What is the formula for joint central moments? Joint central
E of x minus mu x
E of x minus mu x whole power n
into
y minus mu y whole power.
y minus mu y.
E of x minus mu at vector u whole power n equal to double integral of
Double integral minus infinity
x minus mu x whole power n into y minus
E
mu y
of
whole power k
x minus mu
f of x comma y dx is right. for f of x comma dx dv, right? Here also a similar procedure. If we substitute different values, if n is equal to 1, comma k is equal to 0, what is the value here?
E of x minus mu1.
Comma
E of x minus mu x.
e of x minus mu x వస్తుంది. The value for e of x minus mu x is equal to e of x minus mu x value ఎంత? అమ్మా e of x minus mu x value. Equal to 0 because e of x minus mu is equal to e of x minus e of mu. I am writing here u. Okay. Actually, this is mu. Mu x is nothing but the main value. Which is equal to 0. We take n is equal to 1 comma k is equal to 1. What we will get? If n is equal to 1 comma k is equal to 1, which is nothing but
Covariance.
hmm?
Covariance.
Covariance also. Equal to covariance. Okay. These two values are very, very important. These two terms, e of x y, is nothing but correlation of x and y. And also this one is covariance of x and y. Correlation of x and y, and another one is covariance of x and y. Okay. We will get the questions both from theory and problems from these two topics. From these two topics, covariance and correlation. Okay. So major problems ask about the correlation coefficient. In correlation coefficient, we have to find out both covariance and variance. And in covariance also we will get the correlation values. Okay. And we discussed this problem in last class. It is about joint central moments. Joint central moment. These are the major topic in operations on multiple random variables. Operations on multiple random variables. It's followed by joint characteristic function. Okay, joint characteristic function. Okay. Any doubts regarding this topic, please ask.